Hey everyone, this video is about the HP 28C from 1987, and the 28C was the first of a totally new generation of HP scientific calculator, as well as the new clamshell form factor inherited from the 18C business calculator. It also introduced a massive number of new features. It was the first HP calculator to support an algebra system, and HP claimed it was the world's first CAS calculator. But the 28C also supported a much enhanced version of RPN with a variable size stack and support for a large number of new data types. And the 28C also brought a new high-level user-facing programming language called RPL. And it was also the first HP calculator to support named variables and graphing functions. So it was very revolutionary in many ways. And although the 28C was only on the market for a year, being replaced by the 28S, a similar model with more memory and extra features, the 28C really did set the template for HP's scientific graphing calculators for a quarter of a century until the HP Prime was introduced in 2013. And it's easy to forget that at the time the 28C was released, HP was still bringing its Pioneer series of calculators to the market. So the 42S, for example, was released a year later in 1988. But HP always considered the 28C the future of its calculator line. It was built on a new calculator operating system that employed system RPL. This was designed to be the foundation for HP's future calculators. And so, as we'll see, the 28C was really a remarkably innovative device. And hardware-wise, the 28C was almost identical to the 18C, which started development at the same time, but the 18C was fast-tracked to the market in 18 months. And the only hardware differences were an additional 64K of ROM and different keyboard labels. And the original rationale for the clamshell design was feedback that users didn't like the keys that had 3 different labels, and so HP designed a device with more keys split into 2 separate keyboards. And the 28C and 18C were the first HP calculators to be designed using CAD software, and they employed polycarbonate casing, which was designed to protect the calculator from a 1 meter drop on all 6 sides. And with CAD, it was possible to design very tight tolerances. So for example, the half of the case that holds the alpha keyboard deflects slightly to create a latch that holds the case closed. And the 28C was designed primarily to be easily manufacturable rather than repairable. In particular, heat staking was used to reduce the need for screws and also provide uniform keyboard support. So there are no screws on the exterior of the case. The 28C also includes a unique hinge design. The tip of the hinge pin is designed to preload against the inside of the hinge link, and this creates a frictional drag that provides a high quality feeling as the hinge is rotated. Inside each case are 2 flexible membrane keyboards, and they're linked together inside the hinge using a flexible circuit board made from the same material. But the 28C and 18C do have a significant hardware design flaw, and that's with the battery cover. And because the batteries fit very tightly in the battery compartment, this causes a lot of pressure to be put on this cover, and it can cause it to break, especially when the battery compartment is opened. And there are many 28Cs and 28Ss for sale with broken battery covers. The calculator is designed to be used completely opened up. But it can also, you can also fold the alpha keyboard behind the numeric keyboard and rest it on a desk. The 28C has a 4-line 137 by 32 pixel LCD display. And this was a similar width, but twice as many pixels high as displays on the higher end Pioneers. such as the 27S and 42S. The keyboard on the 28C has an excellent tactile feeling, and interestingly, the 28C uses chamfered keys, but there's no labels on the sloping sides. And the Alpha keyboard is in alphabetical order, but includes 3 types of bracket keys, as well as the Guillemette characters that is used for program code. And there's a lowercase toggle, a space key, and also a toggle for alpha entry. The main keyboard has a row of soft keys for navigating the menus. And there's also a red shift key above the numeric keyboard. And the 28C has many menus and commands that are enabled with the shift version of key presses. The 28C uses a Saturn processor running at 640 kilohertz, but it only has 2 kilobytes of usable RAM, which is very constraining. The 28S, which came out a year later, upped this to 32K, which is a lot more practical. And the 28C was also notable because, like the Pioneer series calculators, it doesn't support any removable storage or a way to connect to a PC, so stored information could only be entered through the keypad and not backed up. And so, of course, the 28C is an RPN calculator, and so to calculate 2 plus 3 times 4, you would enter 2, 3, and 4 onto the stack, and then you could hit multiply and plus. And the 28C doesn't have any direct keys for numeric functions. Instead, they have to be accessed from menus. So say to calculate sine of 45, we'd enter 45, and then we would need to enable the trig menu and use a soft menu button. And the 28C was the first HP calculator to modify the traditional RPN interface of 4 stack registers. And it did this in 2 main ways. And so the first change was that the 28C supported an arbitrary level stack. And this allowed mathematical calculations of arbitrary complexity to be carried out entirely on the stack. It also allows programs to be defined externally in terms of the number and type of arguments that they take from the stack and the number and type of result objects they return. And the use of an indefinite stack size as the central user interface is reminiscent of Forth. And so the traditional X, Y, Z, and T registers are now replaced by level numbers, and the names of various stack manipulation commands such as swap, roll, and pick were adapted from Forth. The second major change was the concept of a stack register was generalized to a stack level that can hold an object of indeterminate size. So any object can be manipulated on the stack as a single unit. And besides real and complex numbers, the 28C data objects included real and complex valued matrices and vectors, alphanumeric strings, binary integers, strings, lists, and programs. And so on the 28C, the memory stack is a stack of 5 nibble object pointers, not the objects themselves. And entering different object types, they're identified within the command line by characteristic delimiter characters. And so to multiply a vector with entries 1 and 2 by the complex number I, we would enter the vector using square brackets. And we would enter the complex number I using parentheses. And we can multiply those together to see the result. And this new RPN model was a massive jump in usability from calculators like the 15C, where each stack register could only hold a single real number. And as well as supporting RPN, the 28C could also evaluate expressions as algebraic strings. So to calculate 2 plus 3 times 4, we could also enter that as an algebraic expression using single quotes. And once on the stack, we can hit the eval key to evaluate it. The 28C also introduced a very useful undo operation. And the 28C also supported basic-like syntax for numeric functions. So to calculate sine of 45 using an algebraic expression, we would enter sine and then 45 in brackets. And again, we could hit eval to evaluate that. And we can also build up our algebraic expressions using RPN. So we can, for example, multiply sine 45 by 2 by entering 2 on the stack and then hitting times. And on the 28C, algebraic objects were treated as procedures that were stored in RPN using reverse Polish format. And they were identical internally to RPL programs, except that they were marked as algebraic objects. And so the above algebraic equation would be the same as the RPL expression 45 sine, and then 2, and then times. And you can evaluate that the same way. And so on the 28C, RPN and algebraic expressions were integrated together in a very nice way. And so the HP28C was HP's first calculator with a computer algebra system, or CAS. And as I mentioned, HP claimed it was the first CAS calculator for any manufacturer. And it's hard to evaluate that since there isn't really a clear line in the sand of what constitutes a CAS and what doesn't. The fascinating Casio FX 5500, which was released a year earlier in 1986, did support some formula manipulation operations such as expansion, refactoring, and simplification. And the 28C supports those operations too, but also supports calculus operations. But in many ways, the CAS functionality on the 28C is very rudimentary. It doesn't have a full CAS engine like modern CAS calculators, and you'll quite quickly run into its limitations. But a nice thing about the algebra functions that are available on the 28C is that they're very well integrated with the rest of the system and work the same way as any other function. There's no separate CAS mode like on the HP Prime, for example. And so let's recall a simple algebraic equation from a variable e. And the easiest way to do this is from the user menu. And the user menu displays all the user-defined variables. So we'll pick e, and this is just a simple polynomial. And now if we bring up the algebra menu, we can see three identity operations: collect, expand, and form. And these change the form of the equation without changing its value. So collect, for example, will collect like terms. So, for example, there are two instances of y in this equation, and also two instances of x being raised to a power. So when I hit collect, these will be collected together. And expand does the opposite, expanding powers and products. And the form operation brings up an interactive expression editor that enables you to rearrange algebra according to standard rules. And so there's commutation, association, and distribution operations. And so say if we pick the times operation, we can then use the commutation rule to switch the two arguments. And so different form operations appear in the menu when they're relevant. And the 28C supports differentiation and integration of simple equations like polynomials. So let's exit out of form mode. And let's say differentiate another equation, let's say 3 times x to the power of 3 plus 2x plus 5. And so to differentiate that, we'll need to push the variable we want to differentiate in terms of, so that's x. And then we can hit the differentiation button. And the 28C can solve both algebraic and RPL expressions. And it has the HP solver. So let's use my favorite equation example, the full distance equation, which calculates the distance an object falls in time t. And we can recall that from a variable called full d. And so now we can use the solver function to solve this equation. So first we'll select the solve menu. And we need to use the set EQ function to store the equation in a special variable called EQ. Now we can hit the solver function itself. And so let's enter a value for t, say 10 seconds. And then we want to solve for the distance. And the way you do that is you press the shift key before the variable you want to solve for. We can also enter a value for d, let's say 100 meters, and then solve for t. And the solver can also find the zero of an expression and also the local minima. And the 28C was the first HP calculator to support RPL as a user-facing language, but interestingly, the 28C's user manual doesn't refer to the name RPL, which is an internal HP name at the time. Instead, the manual describes its programming model as keystroke sequences augmented by high-level control structures. And I have a whole separate video on RPL, so I won't go into too much detail here. But RPL was quite polarizing in the HP calculator community. It was seen at HP as a natural evolution of keystroke programming. And a simple RPL program is really the same as its keystroke programming counterpart. So for example, to create a program to calculate the full distance from an argument on the stack, we'd start by using the Guillemette character. And we want to square the argument, then multiply it by a half, and then multiply it by g. And so you enter RPL programs on the stack just like any other value. And so again, this is very similar to a keystroke program that you might create on the 41C or 42S. And so let's go ahead and store this into a variable called fd. And we do that by pushing fd onto the stack and then hitting store. And so now the fd variable has come up in the user menu. And so to run that now, we can enter a time onto the stack and then hit the fd command. And so for simple programs, RPL is very elegant. And RPL adds a bunch of higher level control functions onto keystroke programs. So for example, this is a program to solve the Queen's chess puzzle. And if you're not used to a stack-based programming language like Forth, this might look confusing. But interestingly, the n-queen solution only takes 2 minutes and 27 seconds on the 28C, which is really fast compared to, say, the 42S, which takes about 5 times longer. And the 28C was the first HP calculator with graphing capabilities, and these are available via the plot menu. And so let's enter a simple example. So let's say sine x. And again, we need to use the setEq command to set this as the current equation. And then we can hit the draw command to plot the function. And the plot menu has all the usual functions you need to set the bounding box of the graph and so forth. The 28C can also graph data series. So in summary, the design philosophy for the 28C was to generalize the ease of use, power and flexibility of HP's RPN calculator interface. And the 28C was the first calculator to offer a really smooth integration of RPN and algebraic interfaces. In an issue of HP Journal, which I'll link to in the video notes, there's an article that talks about how the 28C was developed by a small team using what we would call now an agile development methodology with a hardware prototype. And it was certainly one of the most innovative calculators HP ever released. And it's interesting to consider how HP built on the operating model from the 28C. The 28S was released a year later with some much needed RAM, slight processor speed increase and support for directories. And then later the 48 family added a larger screen, hardware connectivity via a serial port, a redefinable keyboard, and full matrix and equation writers. The 48 also supports fractions and a timer. And then the 50G had even a larger screen. It was about 2 times faster, added the SD card support, as well as a totally new CAS engine and support for large integer arithmetic, and a lot more built-in functions. But the core way the 48 and 50G work is very similar to the 28C, and in some ways there's a beauty in the simplicity of the 28C. And I think the clamshell form factor may not have been as well received as HP hoped, but to me the 28C and 28S were quite remarkable and forward-looking devices, and a significant stepping stone to some of the greatest calculators ever made. And so I hope you've enjoyed this video and found it useful, and if you have, please don't forget to subscribe to the channel and hit the notification bell to get alerted of new videos.